lesson, we're going to start out with something called the parallel postulate. This parallel postulate we are not using in proofs. This will be used for a very specific type of problem called the crook problem, which we'll see towards the end of the lesson. So what does the parallel postulate tell us? The parallel postulate tells us through a point not on a line, there is exactly one line parallel to the given line. So they're saying, let's say I have this line, line A, and I have point P. This postulate is telling us that there is exactly one line, not less than one line, not more than one line, exactly one line that can be drawn through P that will be parallel to this line A. Which makes sense, right? You can't have two lines drawn through point P that will be parallel to line A, only one, exactly one line. So the parallel postulate allows us, and like I said, we're only using this in a very specific problem, but it will allow us to draw that line through P and say that it's parallel to A. Okay, and I'll let you know when we're going to need to use that. So let's go down to where it says theorems about parallel lines. Yes, we are going to need to know these theorems, but it's not new memorization. What these theorems are, do you remember the theorems we learned on Friday? Yeah. They're just the reverse of the theorems we learned on Friday. So Friday we were saying, well, if the alternate interior angles are congruent, that's going to yield to parallel lines, right? Well, now it's saying if I tell you you have parallel lines, then you can conclude that the alternate interior angles are congruent. So we're just reversing all the theorems that we learned on Friday. So the first one, if two parallel lines are cut by transversal, each pair of alternate interior angles are congruent. So we're given parallel lines, so we start off with parallel lines. We're given the parallel lines. Then we draw our arrow. And that's going to have us conclude that the alternate interior angles are congruent. So let's say I have, Sam, stop. If I have line A, line B, and line T, and I tell you that line A is parallel to line B. So this is what's given to us. Line A is parallel to line B. Do you all see angle 1 and angle 2 right here? Aren't angle 1 and angle 2 in the armpits of the Z? Well, if the arms of the Z are parallel, then we can conclude that the angles in the armpits are congruent. Those are the alternate interior angles. So if the lines are parallel, then the alternate interior angles are congruent. Last class we had learned if the alternate interior angles were congruent, then we can prove that the lines are parallel. So we're just switching up the order here. All right, next theorem. If two parallel lines are cut by a transversal, each pair of alternate exterior angles are congruent. So again, I'm giving you parallel lines, and then we're going to draw our arrow. We are going to conclude that the alt exterior angles are congruent.
So this usually doesn't apply to proofs?
No, this all applies to proofs.
Oh.
Yeah. Just the parallel postulate doesn't apply to proofs. All these theorems apply to proofs. So once again, if I have line A, line B, and line T, and I tell you that line A and line B are parallel, do we agree, let's call this angle 3 and angle 4, that angle 3 and angle 4 are the alternate exterior angles? So if the lines are parallel, then we can conclude that the alternate exterior angles are congruent. That's what this theorem is telling us. All right, next one. Still copy? All right, next one. If two parallel lines are cut by a transversal, each pair of corresponding angles are congruent. So once again, I'm giving you parallel lines. and we are going to conclude that the corresponding angles are congruent. So I'm giving you parallel lines, and then we'll draw an arrow, core angles congruent. What letter went with corresponding angles? Does anybody remember? What letter, Mia? The F. So what does this look like? So once again, if I have line A and line B and line T, and I tell you that line A is parallel to line B, we can have angle 5 and angle 6 here, which make that F. So if the arms of the F are parallel, then we are allowed to conclude that the angles in the armpit of the F, the corresponding angles, are congruent.
So what's it? I know it's like opposite, like this shortcut. Like, what's the main differences between?
Nothing, just that it's opposite. So it's all going to come down to the proofs. So we use these theorems when in the given I tell you that lines are parallel, and we use the other theorems when we're trying to prove that the lines are parallel. All right, if two parallel lines are cut by a transversal, each pair of interior angles on the same side of the transversal are supplementary. All right, so once again, this time I'm giving you parallel lines, arrow. So we're going to conclude interior, so remember I shortcut that INT, same side. And we don't want them congruent, we want them to be supplement. So interior, same side, sup. I have line A, line B, line T, and I tell you line A is parallel to line B. I don't know if you all remember, but the interior same side, that letter went with a C. Do you guys remember that? Those angles went with a boxy C. So I'm telling you in this theorem, if the arms of the C are parallel, then we can say that the angles in the armpits of the C are supplementary. So this would be sup to this angle. They wouldn't be congruent, they'd be sup. They'd add up to 180 together. All right, next one. If two parallel lines are cut by transversal, each pair of exterior angles on the same side of the transversal are sup. Okay, again, parallel lines, arrow, and now it's not interior anymore, it's going to be exterior, so EXT, ext, same side sup. So again, if I tell you line A and line B are parallel, do we all agree that this angle and this angle are exterior same side? So then we would be allowed to conclude that they are supplement. So this would be a supplement to this. Right, we could cross out this theorem underneath this.
With that last theorem, would there be like a letter for it?
No, so there's two theorems that don't have a letter. The exterior same side sup doesn't have a letter, and the alternate exterior angles doesn't have a letter. So those two don't have tricks. Everything else has a little trick for it. All right, next one. This theorem is called the transitive property of parallel lines. And when we talked about the regular transitive property, it was a whole chain of congruent things, right? If I said angle A is congruent to angle B, but angle A is also congruent to angle C, wouldn't we be allowed to conclude that B and C are also congruent since they're both congruent to A? That's the transitive property. So now we're going to have the transitive property, but this time of parallel lines, which has the same idea. We're going to have a whole bunch of parallel lines and conclude more parallel lines. So if I tell you that A is parallel to B, but I also tell you that B is parallel to C. So if A is parallel to B and B is parallel to C, can't we conclude that A is parallel to C? That's the transitive property of parallel lines. All right, I'm not going to waste our time by proving any of these theorems. Let's cross this all out. We're just going to practice them. So cross out that one, cross out that one. All right, so this next one is for algebra problems only. You could only use this for algebra problems. I will not allow you to use this in proofs. If two parallel lines are cut by a transversal, then any pair of the angles formed are either congruent or supplementary. So how are we going to use this little trick? Because it is a nice little handy trick. Do you see how I have line A? If I tell you line A is parallel to line B. So we have our two lines, and then we have the transversal. Once we have that transversal cutting through, do you all see how all the angles look like they're either acute or obtuse angles? Do you see that? So what we're going to do is I'm going to go ahead and call every angle that looks acute, I'm going to label it with an A. So X, that angle X looks like an A, like it looks like an acute angle. And wouldn't the angle vertical to it also have to be the same? So that's an A. And then go down to line B. Here again we have what looks like an acute angle, and vertical to it would have to also be an acute angle. So I got all my acute angles. I'm going to label all the other angles as O's. Obtuse, vertical to obtuse is obtuse, obtuse, vertical to obtuse is obtuse. All right, so this little trick tells us all A's are congruent, all O's are congruent. What do you think an A plus an O will equal?
180.
180. So all the A's are congruent, all the O's are 180. I'm sorry, all the A's are congruent, all the O's are congruent. Any A plus any O will equal 180. So let's say I told you this angle O right here is 100 degrees. If that angle O is 100 degrees, what does that mean for all the other angle O's?
They're all on 100.
They're all 100. All right, what's the relationship between an A and an O?
They're supplements.
They're supplements, so what will all the A's equal?
80.
80.
Does that mean X will equal 80?
So that means X will equal 80, exactly.
I can see this being useful.
Yeah.
Yes.
All right, are we ready to try some problems?
Oh no.
Let's do this. So sample, anybody still copying this? All right, let's go to sample problem number 1. So I'm telling you in the given information that line B is parallel to line D. Then I'm telling you that angle 2 is represented by 3x squared plus x. And angle 3 is represented by 15x plus 5. And I want to find angle 1. Well, do we agree that angle 1 and angle 2 are the same? Why?
Because they're both acute.
Oh yeah, if we're using the trick, they're both acute, but also what kinds of angles are they? Vertical. So let's say you like the trick. Let's say you like the trick. So if you like the trick, you're saying, A, let me do it in a different color. Oh, freeze on me now. There we go. All right, let's use a different color. We're going to have A, O, O, A, again, AOOA.
AO. Oh.
Okay, so do we agree that in order to, if I find angle 2, that angle 1 and angle 2 are the same, but in order to find angle 2, don't I need to solve for x?
Uh-huh.
Well, in order to solve for x, I need an equation. Well, aren't angle 2 and angle 3 both a's?
Yeah, that means
So
equal.
that means they equal each other. Since angle 2 and angle 3 are both a's, I can conclude that angle 2 is congruent to angle 3, and that's going to be 3x squared plus x equals 15x plus 5. All right, let's say we didn't use the AO trick. Say we didn't use the AO trick. Can someone tell me how else you would know that angle 2 and angle 3 are congruent? Not using the AO trick. How else would you know? Julia.
They're alternate interior.
You got it. Do you guys see the Z? Well, if the arms are parallel, aren't the angles inside the Z congruent? And the armpits of the Z congruent? So that's alternate interior angles. So this angle is congruent to this angle. All right, I'm going to have to factor this, looking back at our equation. Does anybody know how do I know just by looking at this setup that I'll most likely need to factor this? Michael? Good, because of the x squared. The x squared tells us we're probably going to need to factor this. In order to factor this, I need to get everything equal to 0. I need to get one side equal to 0. So I'm going to subtract the 15x and I'm going to subtract the 5. When I subtract the 15x, I'm going to subtract it from underneath the 1x. So this gives us 3x squared minus 14x minus 5 equals 0. All right, so when we come to factor, this is factoring the leading coefficient. So I need to come up with two things that multiply to 3x squared. Well, the only things that multiply to 3x squared, aren't they 3x and x? So that's the beginning of our parentheses, 3x and x. Now you go to the last term, negative 5, and you say, okay, well, I need factors of negative 5. This is nice because it's prime, right? The only thing that multiplies to 5 are 5 and 1. But now because it's negative, one's going to be negative, one's going to be positive, and that's where you can play around a little bit. But because when we check, we're adding to a negative 14, so we're adding to a negative, don't you think the bigger one should be negative? So we have a choice here. I'm going to work with negative 5 and positive 1. All right, we're working with negative 5 and positive 1. Now, our choice can be the negative 5 goes with the 3x, and then the 1 goes with the x. Or the 1 goes with the 3x, and the negative 5 goes with the x. It's a guess. I know you've learned this a million different ways. However you learned it, you should do it. I'm just doing guess and check. I'm hoping it makes sense to you what I'm saying. So when we check this, you need to add to that middle number. And the way you check is you take the variable with the integer and the variable with the integer. So let's say I'm going to do this wrong. Let's say the negative 5 goes here and the positive 1 goes here. When you check this, the 3x gets paired with the number in the other parenthesis. 3x times 1 is 3x. Negative 5 times x is a negative 5x. What's 3x minus 5x? Negative 2x. I don't want a negative 2x. What do I want? A negative 14x. So do these places work for us? No, but if I end up having the 3 multiplied with a 5, 3 times 5, that's 15, right? Isn't that really close to 14? So that's what I'm saying, think ahead. That's what I mean. Like, think of what's going to get multiplied together. So now I'm going to put the negative 5 here and the 1 here, and now I'm going to check it. 3x times negative 5 is a negative 15x. 1 times x is 1x. Negative 15x plus 1x is negative 14x. Isn't that what we wanted? Yeah, so now we got our factors correct. Now we just solve. We got our factors correct, now we solve. So I'm going to say 3x plus 1 equals 0, x minus 5 equals 0, x will equal negative 1/3, x will equal 5. All right, when I plug in that negative 1/3, you end up with 15 times negative 1/3 plus 5. Well, if I do 15 times negative 1/3, that becomes, I keep writing the wrong number. That becomes 15 times negative 1/3 becomes a negative 5. What's negative 5 plus a positive 5? 0. Can I have an angle that's 0 degrees?
No.
No. So I'm rejecting the negative 1/3. So I only have x is equal to 5. Now I'm going to plug that in. 15 times 5 plus 5. 75 plus 5 is 80, which means angle 2 is 80, which means angle 1 is 80. Vertical angles are congruent, right? Isn't angle 1 and 2 congruent? So that's also 80. All right, let's do some proofs. We did find angle 1. Weren't angle 1 and angle 2 the same? Yeah. All right, we're going on to the proof. All right. Can somebody read me this first piece of given? What does this say? Sion?
FA parallel DE.
Excellent. You need to know the parallel symbol. This is FA is parallel to DE. I will tell you right now, we're going to go mark it, arrowheads going in the same direction on FA and DE. If I tell you parallel lines in the given, I need you to use one of those theorems. You're looking for the Z, or you're looking for the F. You're looking for something. I'm telling you parallel lines so you can somewhere tell me there's angles congruent through those parallel lines. That's the only reason I would tell you parallel lines in the given information. All right, then we also have that FA is congruent to DE, and AB is congruent to CD. Hey, now we want to prove that angle F is congruent to angle E. We need to prove these two angles congruent. So my first instinct is use the parallel lines to get F and E congruent. Well, in theory that would be nice, but is there a transversal? So here's AF, here's DE, those are the parallel lines. Is there a transversal connecting F and E?
There is.
A line connecting both of them together?
Yeah.
Which one?
That would be either 80 or FC and BE.
No, I'm saying angle F and angle E, not the parallel lines. I'm saying, is there, if we're looking at angle F and angle E, is there a transversal connecting those two angles?
Okay, no.
No. If there's no transversal connecting those two angles, we can't use the parallel lines to get them congruent. There's no transversal connecting them. Therefore, no parallel lines will be able to get these congruent. So this is now, nothing goes away. Now we're going back to chapter 3. When we can't prove what we want right away, what do we have to do? Prove triangles congruent. So if I can get triangle AFC and triangle DEB congruent, can I see PCTC, F and E? All right, that's now the game plan. So back to these parallel lines. Well, AF and DE are parallel. I did tell you, anytime I tell you parallel lines, I need you to get me angles congruent. So if we use this transversal, what letter did I just create? A Z. And if the arms of the Z are parallel, what do we know about the armpits? They're congruent. Which angles are in the armpits here? Good. Which ones are the alternate interior? A and D. So I can go ahead and I can say angle A is congruent to angle D. So step number 1 is our given. Step number 2, I'm going to say angle A is congruent to angle D. And the reason is going to be parallel lines because I was given parallel lines. Because I was given parallel lines, in my statement, I'm writing parallel lines first. And from those parallel lines, arrow, we concluded that the alternate interior angles were congruent.
Okay, why did you write 3?
That should be 2. Sorry about that. Okay, so because the parallel lines, the alternate interior angles are congruent. All right, so now go back. I have segment FA congruent to segment DE, that counts as a side. I have angle A congruent to angle D, that counts as an angle. Do AB and CD count as a side? No, they're too small. What can I do to get the full sides? Livy.
Can you do like BC reflexive in addition?
You got it. We're going to say BC congruent to BC reflexive.
So we're expanding on our theorems.
So now we're going to have AC congruent to DB addition.
I just realized.
Yes, Simon.
Could you theoretically use these theorems to prove angles congruent?
That's what we're doing. We got angle A and D congruent using the theorem. Yeah. All right, so now I'm going to say the triangles are congruent. So I'm going to say triangle FAC congruent to triangle EDB side, angle, side. And then lastly, we can say angle F is congruent to angle E, CPCTC. Yes.
Wait, could you say that, oh wait, never mind. Sorry, I made a mistake.
Okay. Can I go on to number 3? Okay. So here we have line G is parallel to line H. Remember what I told you. I tell you parallel lines, so you're going to end up using one of those theorems to get angles congruent. Okay, we want to prove that angle 1 is a supplement to angle 2. As of right now, we cannot say that 1 and 2 are supplements. There's no reason to say that. But there is an angle that is a supplement to angle 2 right now that we can declare. Which angle is a supplement to angle 2? Good. I can say angle 2 is a supplement to angle 3, and that's just because they make the straight angle, right? So that's just def of sub. All right, so now this is where we got to make a connection. So I have 2 is now a supplement to 3. I need to get 1 and 2 to be supplements. Right now they're not. But is there a relationship between angle 1 and angle 3? Is there a relationship between angle 1 and angle 3? Yeah. Mia, what is it?
Alternate exterior.
You got it. Aren't they alternate exterior angles? And if the lines are parallel, the alternate exterior angles are what? What's their relationship? Congruent. Not sub, they're congruent. So in step number 3, I'm going to say angle 1 is congruent to angle 3. And our reason is we were given the parallel lines in the given information. So that's why we write that first, parallel lines. And then we draw our arrow because then from those parallel lines, we concluded that the alt exterior angles were congruent. Hey, well, this really helps us. This helps us tremendously because now we have that 2 is a supplement to 3, which means they add up to 180, right? So 2 plus 3 adds up to 180. But now we just figured out that 1 and 3 are the same. So if 1 and 3 are the same and 2 plus 3 equals 180, wouldn't 1 and 2 also have to equal 180? One word, what is that? Not transitive. Remember, transitive only declares congruency. Substitution. So step number 4, I'm now going to say angle 1 is a supplement to angle 2, substitution.
The only reason we can't do A over is because A over is used for algebra problems. Could you, if this happened to be an algebra problem, could you have done it?
Yeah.
Okay, that's right.
Only algebra problems, though. All right, so these are the Crook problems. The Crook problems are actually pretty simple, but for some reason, students always get in their heads with these problems and, you know, sort of freak themselves out, but it's really a very simple process. So these are called Crook problems because you have sort of like a crooked line in the middle, right? We'll have 2 parallel lines. It says that A is parallel to B, and then you have a crooked line or an angle in the middle. The way you go about these Crook problems is you're going to go to that angle, so that's angle C, and you're going to draw a line through angle C. And now what we're going to do is we're going to declare that that line that we just drew is parallel to the other 2 lines. So all 3 of these lines have to be parallel. All right. And then what I want you to do is now once you've have all 3 lines, I want you to take 2 lines at a time and just focus on those 2 lines. And we're going to look for Z's. So I'm going to start with the bottom 2 lines. And if I'm using the bottom 2 lines, do you all see that Z? And if the lines are parallel, aren't the armpits congruent in the Z? So that means this top part of the Z is how many degrees? 40 degrees. Now, what you're not allowed to do is you're not allowed to say that this line that we drew splits angle 1 in half. So you can't just decide that the top of the angle is 40 degrees also. We know it's split, we just don't know in what ratio it's split in. So we know the bottom part is 40. Now we need to find the top part of angle 1. The way you find the top part of angle 1 is you use the other 2 lines. So now I'm going to use the top 2 lines. And I said look for a Z. Well, if I'm doing the top 2 lines, do you all see this Z? The problem is angle 100 in that Z? No. But what's the relationship between angle 100 and this angle? They're supplements, which means that angle has to be 80 degrees, which means the top part of angle 1 is also 80 degrees. So what is the measure of angle 1? No, the full angle 1, 120. So you have the top part of angle 1 is 80, the bottom part of angle 1 is 40, so the full angle is 80 plus 40, which is 120. All right, this next problem is a double crook. Any guesses on why I call it a double crook?
Because there's 2 zigzags.
There's 2 crooks. All right, these are 2 crooks. So we solve a double crook the same way we solve a single crook, but we're just going to double it up. So for a single crook, I drew 1 line. How many lines do you think I'm going to draw for a double crook? 2 lines. I'm going to draw 2 lines. My first line is going to be through the 85. I cannot assume I'm dividing that 85 in half. I do not know what ratio I'm dividing that 85 in. And the second line I'm drawing, take a guess, through what angle? Angle 1. And once again, your plan here is only 2 lines at a time. If you try to do 3 lines or you try to skip lines, it's no good. Only 2 lines at a time. So this time I'm going to start at the top. And if I'm starting at the top, what did I say to look for? The Z. So if I start at the top, do I get a Z here? So that top part of 85 is how many degrees? 75. Well, if the top part is 75 and the whole angle's 85, what does the bottom part have to be? 10. Am I going too fast? Anybody need me to re-explain what I just said there? So you get the idea of just 2 lines at a time, right? So I use the top 2 lines. And anytime we focus in on 2 lines, it's all about the z's. You just keep looking for the z. Yep. So I found my z, and we look in the armpits. So if this armpit's 75, this armpit also has to be 75. But what was the full angle before we split it? 85. So if the top part's 75 and the full angle's 85, the bottom part has to be 10 to add up to 85. We're good? All right, so I did the first top 2 lines. Now I'm going to jump down to the bottom 2 lines. Now we're going to jump down to the bottom 2 lines. And what do I say to keep looking for? Z's. It's all about the z's. So here's a z. But is that 125 in the z? It's a supplement though. So can I do 180 minus 125? And I'm going to get 55. So what does that mean for the bottom part? Yes, Mia?
What if we did a backward Z and made the...
So yeah, okay, so Mia's saying what if we did a backward Z? You'd still be the same process. So if you did a backward Z, it would look like this, right? So that means this would be 125, but we need this angle over here. So then you do supplements again. So you could have absolutely done that. So this is 55, which means the bottom part of angle 1 is also 55. I'm not done. I don't need just the bottom part of angle 1. Don't I need the full angle 1? So now I did the top 2 lines. I did the bottom 2 lines. Guess what I'm going to use now? The 2 middle lines that we drew. Now we're going to use the 2 middle lines that we drew. And what am I looking for? A Z. Do I have a Z? What's the top part of angle 1? 10. So now I have the top part of angle 1. I have the bottom part of angle 1. So I can now identify angle 1 as 65 degrees. Add those 2 together. Yep. All right, number 9. Number 9, there should be, there's something missing here. There should be arrowheads, 2 arrowheads on BC and 2 arrowheads on FE to show that BC and FE are parallel. Right, I'm telling you in the given information that angle 9 is 35 degrees, and we need to find 10, 11, and 12 in any order. Does anybody see how we can find any one of these angles in any order? Ask her.
11.
Good. What's the relationship between 9 and 11?
Supplement.
There's supplement. So I'm going to do 180 minus 35, and we are going to get 145 degrees for angle 11. All right, so that's angle 11. Does anybody see any other angles? Adrian?
Angle 10.
Good. What's angle 10?
Alternate interior angles.
You got it. Do we all see that Z? So that means angle 10 is also 35. Hey, who thinks they know how to figure out angle 12? Michael? Good. Angle 12 and 10 are supplements, which means angle 12 is also 145.
Aren't 12 and 11 exterior?
Alternate exterior angles. Yeah, they are. Very good. And that's why they're the same. All right, I'm going to actually skip number 7 for now because I'm going to do one that's a little bit more difficult than that one. Let's do number 8, and then we'll do independent number 2 at the end. All right, so We're going to do number 8. Again, those arrowheads mean the lines are parallel. Those arrowheads mean the lines are parallel. So using that, I need to find x and y. Does anybody see any way to find either x or y? Eloisa.
I see Y, there's like a Z where 30 is the armpit and Y is the armpit.
You got it. So there's the Z where 30 is an armpit and Y is an armpit. So that means angle Y is 30 degrees. All right, so that's this one, 30 degrees. Does anybody see how we can find x? Sion?
X is 70 because of the upside down F corresponding angles.
You got it. Do you all see this? This one was a little bit harder to see, but do you all see that F that I highlighted in green? It's an upside down F. So remember, if the arms of the F are parallel, the armpits are congruent, which means angle X is 70 degrees. All right, one more problem, then we'll call it a day. We found the Z to find Y and then the F to find X. All right, I'm skipping number 1. Go to number 2 here. Solve for X, Y, and Z. So once again, we're going to use the parallel lines. The difference here is we have 3 different transversals for the parallel lines. Let's go through all the transversals. Do you agree that I think the most obvious transversal is this pink one? Do you all see that?
Yeah.
All right, there's another transversal. Do you all see this green one? All right, there is a third transversal. Who thinks they know the third transversal for the yellow lines? It's the third transversal. Yeah. Stumped you, Sam?
Like the bottom.
You got it, the bottom line. Do you all see that one? All right, so all 3 of those transversals can help us out here, all 3 of those transversals. So let's go one step at a time. Can't look at it all together because then we'll get dizzy. So we're sticking with the parallel lines. All right, let's use this one transversal first. Why do you think I used that transversal? What have we created? A Z, which means angle Y is 50. All right, now I'm going to go to this top transversal. What have I created there?
An F.
Good. I know it's a little awkward, but do you guys see that F? Hey, so what does that mean? Look in the armpits. What does that mean for angle X? X is 60. All right, now which transversal am I going to go to? The bottom one. And then what letter is that? An F, but this time it's a little bit tricky. So do we agree this armpit is Z, but the other armpit's not just 40, it's not 50. What is it?
50 plus 40.
50 plus 40, which is 90, which means angle Z is 90. All right, we are done for the day. I am taking off numbers 20, 22, and 27 in your homework. So I'm taking those off. We're done.